Hi everyone, I welcome you to my channel, and today we are going to discuss questions on continuity. And this will be lecture 1 on continuity, and this video is especially for the students who will be appearing class 12 boards, and this will help the students for CBSE, ICSE or other states boards. So this video will be very short, and we'll discuss only a few questions. Okay, so please watch the video completely, and please note down, and related more questions you please practice for your exams. Okay, today we'll discuss, this will be the first questions to discuss today. Define all points of discontinuity of f, where f is defined by the function fx is equal to x by mod x, where x less than 0, and minus 1 for x greater than or equal to 0. What's the questions? Find all points of discontinuity. Okay, this is most important part of the questions. We need to check all the points of discontinuity. Okay, now before we start the steps, let us try to see what is a possible point, what is a probable point of discontinuity. Okay, for x less than 0, we know that fx will be, fx is equal to x by mod x. Okay, then which will be equal to minus 1, which is a constant. Similarly, for x greater than 0, then fx is equal to minus 1. That means for all value x less than 0 or x greater than 0, the function is obviously continuous. Okay, now only one probable point of discontinuity is x is equal to 0. Therefore, we need to check the continuity at only one point, that is at x equal to 0. So we just can solve if the function, and apart from that, if a function to be continuous at a particular point, the left hand limit at that point and right hand limit at that point should be equal to the functional value. Okay, so here only probable point of discontinuity is x equal to 0. So therefore, we need to check the continuity at x equal to 0. So just solve one by one. So just start left hand limit. So left hand limit x approaches to 0 minus fx. Okay, and limit x approaches to 0 minus, that means x is approaches to 0. Okay, from the negative side. So therefore x value is negative. Okay, x is less than 0. So for x less than 0, then fx will be replaced by x by mod x. Now since x is approaches to 0, that means x value is very close to 0, but which is negative. So therefore the mod x will be equal to minus x. So just can move to the next page. Okay, so limit x approaches to 0 minus, this is x, and mod x will be equal to minus x. Okay, this is equal to limit x approaches to 0 minus, so you cancel out, this is minus 1, so left hand limit is equal to minus 1. Now let us find out the right hand limit. So similarly, we can just find out the right hand limit x approaches to 0 plus, okay, f of x. Now for x is approaches to 0 from the positive side, so therefore the sign of x is what? Sign of x is positive. So when sign of x is positive, so we have to select the function correctly. When x is greater than 0, then fx value is constant, it's given as minus 1. So therefore fx to be, okay, fx to be replaced by, okay, this fx to be replaced by minus 1. This is limit x approaches to 0 plus, this is minus 1. So this is equal to minus 1. So we got the left hand limit as minus 1, right hand limit as minus 1, and also we need to find the functional value. Also f of 0. If x is equal to 0, let us check the function. Right? For having said this, that is x is either greater or equal. When x will be greater than or equal to 0, then functional value will be minus 1. So therefore, okay, yes, here. So functional value is given as minus 1. So you can combine 3. This is left hand limit. What is the left hand limit? Left hand limit is equal to minus 1. What is the right hand limit? Right hand limit also minus 1. And the functional value also given as minus 1. So here you can just write left hand limit equal to right hand limit is equal to functional value. So let the limit equal to right hand limit is equal to functional value. Therefore, this function is also continuous at x equal to 0. So initially we thought we just took 0 as a probable point of discontinuity, and we have shown that actually this is not a point of discontinuity. Therefore, we can just conclude. So you can just see the questions. What is the questions? That find all the points of discontinuity. So we have not seen any point of discontinuity. Therefore, this is a continuous function. So you can just write at last that there is no point of discontinuity. So it's a very important and very simple questions. So the marks allotted for such questions could be of 2 marks or 3 marks according to the new pattern. Okay, just we'll move to our next questions now. Right? So what is this question? Okay, like these questions are very common, right? Very common and very important. Like these questions, like finding out the value of a constant. Okay, like these questions are very common. You need to practice like these questions, more questions. So what is the question? For what value of k is the function fx sine 5x by 3x plus cos x for x not equal to 0 and fx equal to k for x equal to 0? Continuous at x equal to 0. That means it's given that the function is continuous at, if the function is continuous at x equal to 0, then what will be the value of k? The question is very, very simple. So we can just start the steps like that. Okay. If fx is continuous at x equal to 0, remember one thing, that while you are writing steps for your board exams, there are certain important steps to be written. Okay, if fx is continuous at x equal to 0, then okay, let the limit. Okay, let the limit and write the limit, right? And a functional value at x equal to 0. That means you can just write. In fact, you don't need to write two steps. You can just write either this steps, or you can write limit x tends to 0 fx, right? Limit x approaches to 0 fx is equal to f of 0. Okay, so we need to use these conditions to get the value of k. So one by one, we'll just try to find out left hand limit, right hand limit, and functional value. Functional value, of course, it's given for x equal to 0, f0 is equal to k. So we'll just try to find out the left hand limit and right hand limit. So let's move to this one, the next page. Yes. Okay. Say we'll just start with left hand limit. Okay, left hand limit. Or in fact, instead of finding out left hand limit, right hand limit, for these questions, I'll just go back to the questions once more. Okay, let me go back to these questions. Right, these are the questions. So since it's given x not equal to 0, so you may avoid writing left hand limit, right hand limit. In fact, you can just write in this way. Okay, yes. So you can just write. So now limit x approaches to 0 fx. Fine. Because limit x approaches to 0 means you can approach 0 from the left hand side or from the right hand side. Okay, for both the cases x is not equal to 0. So you can avoid writing left hand limit or right hand limit when it's given, okay, x not equal to 0. But of course it depends on questions. So limit x approaches to 0. So fx value we are going to write, that is sine, this is given as what? Sine 5x by 3x plus cos x, right? Yes. Yeah. Sine 5x by 3x plus cos x. This is given. Fine. So if we use the limit in both the terms, that is sine 5x by 3x plus limit x approaches to 0 cos x. Okay, now limit x approaches to 0, these steps can be written as sine 5x. So instead of 3x, you can just write 5x. Okay, so you can write that is 5 upon 3 plus for x approaches to 0 cos x equal to 1. So you got this, that is 5 by 3 plus 1. Now we know for limit x approaches to 0, sine 5x by 5x is equal to 1. So this gives us what? You can just write these steps here. 5 by 3 plus 1. So if you add this is 8 by 3. So you got the limit, that is the s 8 by 3. Now what is the functional value? So functional value as, okay, the functional value is given as, functional value is given as k. So we can compare the limits with the functional value. So our value of k is, okay, therefore you can just write, therefore k is equal to 8 by 3. Because the limit is equal to the functional value and functional value is given as k, so therefore k value is equal to 8 by 3. So this is a very simple question. Okay. Next, this is a very important question, that find a value of p and q. So two unknown terms you need to find out. P and q. We need to find the value of p and q. Okay. It has got little more steps than the question that we have solved. Okay. Slowly we'll be taking such questions. Okay. And in the next video we'll be taking questions based on this type. Okay. In the lecture 2. And please, if you have not subscribed my channel, please do subscribe. And these days you will be keep getting such videos. This I'm starting with the continuity. And the previously I uploaded videos on limits, and in case you need a little practice on limits, you can just go through, refer to the previous videos on especially on limits. Okay, now so just solve this question. Find the value of p and q for which fx equal to 1 minus sine cube x by 3 cos square x for x less than pi by 2, fx is equal to p for x equal to pi by 2, and q 1 minus sine x by pi minus twice x whole square for x greater than pi by 2 is continuous at x equal to pi by 2. So if the function is continuous at x equal to pi by 2, the question is very simple. You need to find the value of p and q. Okay, so we can just start steps like that. If, okay, let's start the solution. If fx is continuous at x equal to pi by 2, then limit x tends to pi by 2 fx pi by 2 minus, that is less than limit equal to limit x tends to pi by 2 plus fx right hand limit is equal to the function value at pi by 2. Okay, if the function is continuous, then we will get the steps. Left hand limit equal to right hand limit equal to function value. So mark this is 1. So step by step we are going to solve this. Okay, we'll get the steps. Limit x tends to pi by 2. Okay, say minus fx. So this is left hand limit. You can just mark this is left hand limit. Limit x tends to pi by 2 minus fx. So limit x tends to pi by 2 minus fx. Now let us check what is fx. Okay, for x less than pi by 2. Okay, x approaches to pi by 2 minus means x is less than pi by 2. Okay, what is the value? 1 minus sine cube x by 3 cos square x. So we need to okay, 1 minus sine cube x, okay, 3 cos square x. Okay, that is 1 minus sine cube x by 3 cos square x. Yes, 3 cos square x. Now, before we go, like before we find the limits, let us check this particular function, that is 1 minus sine cube x by 3 cos square x. For x is equal to pi by 2, okay, this is sine pi by 2 is 1, so 1 minus 1, this will be 0. And for x equal to pi by 2, that's denominator also 0, so this expression will be in indeterminate form, that is 0 by 0 form. So try to remove the indeterminate form. To remove the indeterminate form, we'll just follow a simple steps. What I'm going to do is, we'll try to factorize this. Okay, 1 minus sine cube x. If you factorize this is 1 minus sine x, that is 1 plus sine x plus sin square x. Which formula you use it? That is aq minus bq. aq minus bq means a minus b, a square plus ab plus b square. Fine. And 3. This cos square x will convert to sine. That is 1 minus sin square x. So 1 minus sin square x can be written as 1 minus sin x and 1 plus sin. You can just write it this way. So what you can do is, we can cancel this. 1 minus sin x, 1 minus sin x, we can cancel it. So just can move to the next phase, right? So this is limit x tends to pi by 2 minus, so numerator 1 minus sin x plus sin square x. So 3, so 1 minus x got cancelled out. So what is left out? 1 plus sin x. So now we need to check whether a determinant form is there or we have successfully removed the indeterminate form. For x equal to pi by 2, right? So sin pi by 2, 1 sin, this sin x, this sin x, sin square x also 1. So and denominator also non-zero. So we can just put the limits. So if you put the limit, this is 1 plus 1 and plus 1. Because x approaches to pi by 2, the sin x gives us 1. So this is 3 and this is 1 plus 1. So this is the 3 and 3 will get cancelled out, so we'll just get half. Okay, so this is the left hand limit. Left hand limit is equal to half. Now let us try to find out the right hand limit. Okay, right hand limit x tends to pi by 2 plus fx. Fine. So limit x tends to pi by 2 fx. So what is the value of fx? You need to change this. Okay. Yes. What is the value of for x greater than pi by 2? So when x will be approaching through pi by 2 plus, that means you are approaching pi by 2 from the right hand side. So x will be slightly greater than pi by 2. So you can take the function as q into 1 minus sin x by pi minus twice x whole square. So you can use this. Okay. Okay. Q into 1 minus sin x. Okay. That is pi minus twice x whole square. So you can just check once. Okay. Q into 1 minus sin x pi minus twice x whole square. Okay. Fine. Yes. Right. Now let's check the indeterminate form here. So for x equal to pi by 2, so numerator this is equal to 0, and for x equal to pi by 2, so pi by 2, that is 2 to cancel, pi minus 1, this is also 0. This is also 0 by 0 form. This is also given in 0 by 0 form. Okay. Right. 0 by 0 form. Now, how to remove this 0 by 0 form? To remove this 0 by 0 form, this is using a simple technique. So, let this pi minus twice x will use a new variable. Say pi minus twice x equal to y. The moment you take a new variable, the same time you try to change the limit. So for x approaches to pi by 2. So if limit x approaches to pi by 2, for x approaches to pi by 2, that means if this x value is very very close to pi by 2, then obviously y will be approaching to 0. Okay, y will be approaching to 0. So we can just use this space. So this is equal to limit y approaches to 0. Okay. Fine. So pi minus twice x, we are assuming as y. So this will be y square. Fine. Then 1 minus sine. Okay. What is the value of x? X value will be here. You can just calculate the value of x. So this will be pi minus y equal to twice x. So this gives you, that is pi by 2 minus y by 2. That is x value is equal to pi by 2 minus y by 2. So pi minus twice x equal to y. So value of x will be equal to pi by 2 minus y by 2. So we need to change the value of this x. That is pi by 2 minus y by 2. Okay, and then what's the next steps? Limit y approaches to 0. Okay, I'll just repeat once this particular steps. First we'll check this particular form, right? And then we have seen that it is given in 0 by 0 form. So just try to substitute 5 minus twice x as a new variable. Okay, that is y. Then for x approaches to pi by 2, then y will be approaches to 0. Okay, because if this x value is very close to pi by 2, that is pi minus twice x will be approaches to 0. So y approaches to 0. So what's the next step? Will be twice approaches to 0. This pi minus twice x will be replaced by y. Then same time you need to find the value of x. Then we got a value of x as pi by 2 minus y by 2. So replace that value. So let's see the next steps. What's the next steps? This is equal to, okay, limit y approaches to 0. This is y squared. Fine. And 1 minus. Fine. This is sine pi by 2 minus y by 2. So that is sine pi by 2 minus theta is cos theta. So this is cos y by 2. So you got this steps. 1 minus cos y by 2. Now next. Okay. Limit y approaches to 0. This is y squared. Okay, again it is in a 0 by 0 form. So we are going to use 1 minus cos theta formula. 1 minus cos theta. So we know that 1 minus cos theta is equal to 2 sine squared theta by 2. We are going to use this formula, right? 1 minus cos theta is equal to 2 sine squared, okay, theta by 2. So what is theta here? Y by 2. So theta by 2 means y by 4. So 2 sine squared 1 minus cos theta is 2 sine squared theta by 2. Fine. Next. Okay, I'll just miss the term, I hope. Okay, we just need to check that. Right? Yeah, this term, that is q. We just missed the this value, that is q. Okay, let's see this. Okay, then next this steps. Yeah, here just we miss this q. Q is here and q, right? So you can just write this is 2q. Fine, 2q. So limit y tends to 0. Okay, 2q. So this is sine squared y by 4. So you can just write sine y by 2 and sine y by 4 and sine y by 4. You can write like that. Sine squared y by 4 can be written as sine y by 4 and multiplied by sine y by 4. So this y can be written as y by 4 into y by 4. You can write y squared, you can just write y by 4 into y by 4 and it can be multiplied by 16 because here sine y by 4, so you need to use the sin x by, you need to use an important theorem, limit x is to 0, sin x by x is equal to 1. We're going to use this theorem. So therefore, for sine y by 4, you need y by 4. So y is already there, just you are writing y upon 4. Here also, similarly you are this sine square y by 4. For this sine y by 4 also you need y by 4. But this y into y square is already there. So which extra term you have written? 4 into 4, 16. So please multiply by 16. So if you take the limit now, right? If you take the limit, so what do we get? Limit. So if you take limit, so you can take limit now. 2q is there. Fine. So sine y by 4 by y by 4 is 1. Sine y by 4 by y by 4 is 1. So you'll just get 2q by 16. Right? So you'll just get q by 8. Fine. So you got the right limit as q by 8. So let us check what are the steps. Okay? Yes. So let the limit. So you got let the limit as equal to half. And right limit we got as q by 8. And apart from that also, we need to take the questions. The question here, for x equal to pi by 2, the functional value is given as p, right? Functional value is given as p. So you can compare all the steps now. Okay, yeah, we can compare all the steps. So here functional value, so just can take the half of 1. So using 1, okay, if we use 1, okay, 1 implies, so left hand limit, right? Left hand limit we got as half, and right hand limit we got as q by 8, and functional value is of course it's already given. Then functional value, next step, next question. Okay, yes, functional value is given as p. So you can just use this. Functional value is given as p. Yeah, so let us check this. I hope here. Yeah, right. Functional value is given as p. Yes, fine. So we got this. Left hand limit equal to half, and right hand limit is q by 8, and functional value is given as p. So therefore, we can just conclude p is equal to half. So we got p equal to half. And what is the value of q? So q by 8 is equal to half. So you can cancel. So this implies q is equal to 4. So you got p equal to half and q is equal to 4. Right? Q is equal to 4. So finally our answer is, okay, yeah, these are questions. So what is the value of p and what is the value of q? So we for this question we need to calculate the left hand limit as well as the right hand limit, and functional value. We have to compare the functional value, and steps are also very, very simple, but it's a very important questions. So obviously you can expect the minimum 3 marks in these questions, or sometimes the 5 marks can also be allotted. Okay, and thank you so much for watching my video, and next video will be solving few more questions on continuity. Until then, bye bye, take care, and if you have not subscribed my channel, please do subscribe. Until then, bye bye.